Hello and greetings to all. My name is Payal Madhav Godke and I am a second year electrical engineering student studying at MVP's KBT COE. Today, I am here for a real world assignment on design of on-grid solar PV system for household under the course of power generation technologies. So, let us proceed. Firstly, what is solar energy? Solar energy is one of the most abundant renewable resources found on the earth. It is captured using solar photovoltaic panels, which convert sunlight into electricity, or through solar thermal systems, which use the sun's heat for heating water or air. The solar system design. The first step is that we collect the user's energy consumption for the last 12 months and calculate the yearly consumption. So here is the data from January 2024 to December 2024, and the total units consumed in this 1 year is 1725 units. We have already calculated the yearly consumption, that is 1725 units per year. Now the next task is to calculate the average monthly consumption by considering only 10 months to account for system efficiency. So when we divide 1725 by 10, we get the monthly average, that is 172.5 units per month. Then the next task is to determine the average daily consumption based on the monthly average, which is equal to 5.75 units per day. So now the next step is determination of required solar system capacity, which is equals to daily consumption divided by site insolation. With the help of the map given on the slide, we can find out the insolation for a particular site. So for Nasik city, solar insolation for polycrystalline panel is between 4 to 4.5 units per kilowatt, and for monocrystalline panel is 4.5 to 5 units per kilowatt. So considering that for 1 kilowatt system generates 4.5 units per day, required solar system capacity is equals to 1.27 kilowatts. So the next step is calculation of number of panels required, which is equals to system power divided by module power. Considering a 200 watt module power, so by dividing the daily consumption in watts, that is 1270 divided by 200, that is the module power, we get 6.3, that is 7 panels of 200 watt. But here was a customer demand. Electricity bill showed energy consumption as 1725 units per year. On verification, an error in the energy meter was identified. Actual monthly consumption was found to be around 250 units. Future consumption is expected to rise to 300 units per month. Hence, revised yearly consumption is estimated as 300 into 12, that is 3600 units per year. Earlier calculations were based on the energy bill data, but now they will be done as per the updated consumption. Now, the updated design. We have to follow the same steps that we have followed earlier. We already have the yearly consumption, that is 3600 units per year. Now we'll calculate the average monthly consumption by considering the 10 months, which is equals to 360 units per month. By dividing by 30, we get the daily consumption, that is 12 units per day. Now, we'll calculate the solar system capacity by dividing by 4, as they want a polycrystalline panel, which is equals to 3 kilowatt. And then we calculate the number of panels by considering one panel of 550 watt. So the number of panels required is 6. So the next step is component selection. First one is solar panel. 550 watt Vikram company's panels are selected. Their electrical parameters are: peak power is 550 watt, maximum voltage is 41.9 volt, maximum current is 13.1 ampere, open circuit voltage is 49.7 volts, a short circuit current is 13.82 ampere. Then next is the inverter. 3.3 kilowatt Havells company's inverter, which has the efficiency of 97%. Input DC parameters are: maximum input voltage is 550 volt, Startup voltage is 70 volt. Rated input voltage is 760 volt. Maximum input current, uh, that is MPPT, is equals to 12 ampere. Now the output AC parameters. Rated power is 3300 watt. Rated output current is 14.3 ampere. Maximum output current is 16 ampere. Grid voltage range is between 180 VAC to 276 VAC and the frequency is 50 Hertz. So now the next component is meter. We have two meters, generation meter and a net meter. Generation meter is used to calculate the generation from the solar system, and net meter is used to calculate the import and export of the generation or the energy. Next, for the DC protection, we have DC-DB or DC distribution box, and for AC protection, we have AC-DB or the AC distribution box. Next, external protection. For external protection, we have lightning arrestor. And next is earthing. We have AC earthing, DC earthing, and lightning arrestor earthing. Single line diagram. Firstly, the output from the solar is DC, which is sent to the DC protection, that is DC distribution box. And from DC distribution box, it is sent to the inverter. Inverter converts the DC to AC. Then the AC is sent to AC distribution box, and from that it is sent to the generation meter. Then the generation meter sends it to net meter. Net meter calculates the import and export. Next we have estimation of performance and economics. So now we'll calculate monthly savings, which is equals to monthly consumption into unit rate. So monthly consumption is around 300 units, and for 0 to 100 units, cost of 1 unit is equals to rupees 4.28 rupees, and for from 101 to 300 units, cost of 1 unit is equals to rupees 11.10. So monthly savings is equals to 100 into 4.28 plus 200 into 11.10, that is equals to 2648 rupees, and yearly savings will multiplied by 12, that is 31,776. Payback period. So payback period can be calculated as investment cost divided by yearly savings. So investment cost is 1,37,000 rupees and yearly savings is 31,776, which is equals to 4.3 years. CO2 reduction is equals to consumption into emission factor. Emission factor for India is equals to 0.727 kilogram CO2 per unit. Hence, CO2 reduction is equals to 3600 into 0.727, which is equals to 2617.2 kilogram CO2 per year. Conclusion. The 3.3 kilowatt rooftop solar system is expected to generate around 3600 units per year, reducing approximately 2617.2 kilogram CO2 per year, contributing to cleaner environment. The system's payback period is estimated at 4.3 years, after which all the electricity generated will be effectively free, resulting in direct financial savings while promoting sustainable energy use. Solar system installation, Sonzam Nasik. So 550 watt 6 Vikram company solar panels are installed in series connection for 3.3 kilowatt system. They also have a walkway for solar panel cleaning. Acknowledgement. I would like to express my sincere gratitude to Mr. Samadhan Jadhav sir, owner of Sri Sai Enterprises Nasik, for providing valuable insights and real-life site details related to the solar power system. His practical knowledge and guidance greatly helped me understand the real-world aspects of solar energy generation. I am also deeply thankful to Professor Prasad Joshi sir, my power generation technology teacher, for his continuous support, encouragement, and guidance throughout the completion of this assignment. His expertise and direction were instrumental in enhancing my understanding of the subject. Lastly, I would like to thank everyone who directly or indirectly contributed to the successful completion of this assignment. Thank you.